Welcome back to the Pony Math Teacher, and we are working on expectations. That's what we're working on. So make sure you're making notes to your future self. So make sure you can read them. They're not just for points. They're not for a grade. They're just so you can actually use them on activities and practice, and make sure that you understand how to write notes effectively and systematically, so you can prove to yourself, okay, I am organized. I know how to find it quickly. And that's how we use the table of contents. So make sure these are notes to your future self. Pause the video, go forward, go backward, change the playback speed, whatever you need to make sure that you are successful with this video. So we are actually going to do a 2-pager today. So again, it's going to probably go a little long, but I'm going to try to keep it under 15 minutes. So we're solving proportions, pages 11 and 12. And we'll get started. Alright, so solving proportions. We are going to start with, that's page 2. I don't want page 2. I want page 1. There we go. With some definitions. So we are going to define equivalent. We're going to define ratios and proportions. So equivalent means equal. Right? Ratios, this is a plural, so it is fractions that compare two numbers. And then proportions are two equivalent ratios. And we're going to use these words in our practice problems for our notes, so just making sure that we actually know we're all starting at the same base knowledge. Okay, so we're going to draw a big box, and we're going to call these equivalent ratios. Example 1, so this is just a bunch of copying, and then we'll go over it. 7/8 and 49/56. Yes, no, why? Example 2, 3, 6, and 15/18. Yes, no, why? And then our final question, are these proportions? So remember, it is expected that you are pausing the video so you have time to write this down. So when I'm done writing this box, pause it. Alright, pause, write this down, hit play. Okay, so equivalent ratios. Are these equivalent ratios? Is 7/8 the same as 49/56? Yes. And why? Because 7 can be multiplied by 7, and 8 can be multiplied by 7. And if you multiply by 7 over 7, that's doing the same thing on the top and the bottom. You're really multiplying by 1, which is the multiplicative identity. So I'm not changing the value, I'm just making it look different. 3/16, 3/6, and 15/18. There we go. Well, okay, I can do 3 multiplied by 5 and 6 multiplied by 3. But 5/3 is not the multiplicative identity. It's not a convenient name for 1, so this is a no. Now, are these proportions? So proportions are two equivalent ratios. This one is a proportion if I put an equal sign in between to show that they are equivalent ratios. This one would not be proportion because they are not equivalent ratios. All right, so we are going to have a little mini to check if they are proportional. Okay, so if something says, hey, you have these two fractions, are they proportional? So one of these would be, one example of this is this. Now they're using decimals here simply for the sake that we can't process decimals as quickly. We process fractions with a clear integer numerator and integer denominator much quicker than we do with decimals. So I can't right away, without some deep processing, say yes, these are proportional, or no, they're not proportional to each other. I have to do some math to figure it out. If they had just left it without decimals, I would have done it much quicker, and then this process wouldn't have made much sense. But In order to figure out if they're proportional, I need to figure out, does the left-hand side equal the right-hand side? We don't know that. That's why there's a question mark. So in order to make the left-hand side and the right-hand side have no denominator, I can just multiply them out. I'm going to multiply by the denominator on both sides. This makes 1. So I'm going to end up with 0.25 hundredths and 1.25 times 0.6 all divided by 2. So this first step was to multiply by denominator number 1. And I just said number 1 because it's the first one on the left. Because now I'm going to multiply by denominator number 2. Yay! Multiply by denominator number 2, which in this case is actually 2. So notice that 2 divided by 2 makes 1, so that disappears because it has to be the multiplicative identity. And now I can actually simplify as we go. So what's 2 times 25? 50. So I know this is 0.5. And 125 times 6, so that's 600, plus 120 is 720. 720 plus 30 is 750. So 7.50. Nope. There's an extra decimal in there. 0.75. And that's why multiplying with decimals is tricky. Because there's 3 numbers behind the decimal point there. And now, is 50 hundredths the same as 75 hundredths? No! So, this is not equal, which means they are not proportional. Alright? And there we go. So they are not proportional. That would be your final answer. Wow, we actually did a lot on that first page. Woohoo! So we might go into a second page. That's why we had 2 reserved in our table of contents. So I think I'm just going to go to the next page. That way I have more room. We're going to do 3 examples. So about halfway down your page, drop a horizontal line, and then we're going to divide that top section in half. So we have 3 examples. First example, and these are all using variables. Now we actually can solve things with variables. So I have 5 over a equals 10 twelfths. So this is a proportion. I am saying the ratio of 5 to a is equivalent to the ratio 10 to 12. But what value of a makes this true? That's what I'm solving for. So it's the same process as we just had. I'm going to multiply by the first denominator on both sides. So I'm going to end up with 5 equals 10a over 12. I'm going to then multiply by the second denominator on both sides. I'm going to end up with 60 equals 10a. There's a shortcut. For proportions, it's all understood. It's great if you want to show me your work. It's great if you want to show me this intermediate step. But if you can see that it's 5 multiplied by 12 and 10 multiplied by a, you can skip and just show that step. For proportions, that is a typical thing to do, is just skip to that step. Alright, so I'm going to divide by 10, divide by 10. I'm still showing this work though, because I want to be clear on what I'm doing, and I'm checking that I made sure it equaled 1. If you don't draw that divide by 10, you may skip and do divide by the wrong number and not realize that's not 1. Alright, so it's a nice check step in between. 6 equals a, or you could write it as a equals 6. Both of these are right. It doesn't matter which order you write where the variable is. Okay? And this value will make a proportion. If a is 6, this will be a true statement. And 5/6 is equivalent to 10/12. Alright, so make sure you're doing your first denominator, second denominator, and then you're eliminating your coefficient. Alright, making it go to 1. Example 2. 12/7 is equivalent to 6 over y. Alright, so we're going to do the shortcut. It's 12 times y equals 7 times 6. Alright, now you may still make a mistake here, so if you want to write 7 times 6 and then the next line make it 42, you can. You don't have to go this fast to do this much in one step. It's just an option. Dividing by 12. I'm going to simplify this. So 42 over 12, both have 2 in common. Oh, yeah, we'll do 2. We'll do 2 first. So that's 21 over 6. They have 3 in common, so that's 7 over 2. So this is 7 halves. There we go. So if y is 7 halves, then that will be true. So I showed a lot less work than I was going to. But you could also show divide by 2 here, divide by 2, divide by 3, divide by 3. So the main thing is you're dividing by the same number in the numerator and in the denominator. And hey, we're going to make this under 15 minutes. Woohoo! All right. Example 3. This one gets more complicated. Now you could write it with the parentheses on the x plus 3 quantity or not. The parentheses are assumed because remember fraction bars are a grouping symbol. It's assumed that x plus 3 quantity is a group. So when I do my denominator, cross-denominator multiplication, I'm going to have 5 times x plus 3, all in a quantity in parentheses. If you don't use the parentheses, you're going to mess your whole thing up because you're not going to get the right answer. You have to have the parentheses because we're going to distribute the 5 to the x and the 3. You can't leave that 3 out. So when I distribute, if it helps you, draw the rainbows as you do it. 5 times 3 is 15 equals 8. And then I'm going to subtract 15. Making sure that it equals 0, the additive identity. Negative 7 divided by 5 must equal 1 because it's the multiplicative identity, and I end up with negative 7/5. I'm going to do the check step just because I still have 4 minutes. So I'm going to have negative 7/5 plus 3 over 4 equals 2/5. This is my check step. So negative 7/5 plus 3. I want to make this have a common denominator so I can add. This 3 is going to turn into 15/5 because that's the same as 3. Alright, negative 7/5 plus 15/5 is 8/5. Divided by 4 is the same as multiplying by the reciprocal, which is 1/4. And 8 divided by 4 makes 2, so that is 2/5. Yep, rewatch that. Does it make sense? If you change this to a 6, could you solve it and then do the check step? All right, that's your challenge. And then our comprehension questions are the same as before. Compare and contrast equation with proportion. Are they similar? Are they different? How do they help each other? And then do you still use scales when you're solving your equations? And then create your own proportion situation and challenge someone else to solve it. You may have to teach them first, but challenge them to solve it or have them make one for you and then you solve it. All right, thank you for listening and have a great day.